In mathematics, the sine function or signum function is an odd mathematical function that extracts the sign of a real number. In mathematical expressions, the sine function is often represented as Sgn. Definition: the signum function of a real number x is defined as follows. Properties: any real number can be expressed as the product of its absolute value and its sine function. It follows that whenever x is not equal to 0, we have similarly, for any real number x, the signum function is the derivative of the absolute value function. Note: the resultant power of x is 0, similar to the ordinary derivative of x. The numbers cancel and all we are left with is the sine of x. The signum function is differentiable with derivative 0 everywhere except at 0. It is not differentiable at 0 in the ordinary sense, but under the generalized notion of differentiation in distribution theory, the derivative of the signum function is 2 times the Dirac delta function, which can be demonstrated using the identity as the Heaviside step function using the standard h equals 1/2 formalism. Using this identity, it is easy to derive the distributional derivative. The signum can also be written using the Iverson bracket notation. The signum can also be written using the floor and the absolute value functions. 4. A smooth approximation of the sine function is another approximation which gets sharper as. Note that it's the derivative of. This is inspired from the fact that the above is exactly equal for all non-zero x if, and has the advantage of simple generalization to higher dimensional analogues of the sine function. See Heaviside step function, analytic approximations. Complex signum. The signum function can be generalized to complex numbers as for any z except z equals 0. The signum of a given complex number z is a point on the unit circle of the complex plane that is nearest to z. Then, for z0, where arg is the complex argument function, for reasons of symmetry, and to keep this a proper generalization of the signum function on the rails. Also in the complex domain one usually defines for z equals 0. Another generalization of the sine function for real and complex expressions is Sgn, which is defined as, whereas the real part of z is the imaginary part of z. We then have generalized signum function. At real values of, it is possible to define a generalized function version of the signum function, such that everywhere, including at the point, this generalized signum allows construction of the algebra of generalized functions. But the price of such generalization is the loss of commutativity. In particular, the generalized signum anti-commutes with the Dirac delta function. In addition, cannot be evaluated at, and the special name is necessary to distinguish it from the function.